Is our universe infinite? Sooner or later, this question is certain to occur to many of you. Unfortunately, today's science is incapable of providing a definite answer to it, but it can claim with assurance that there was a beginning of the universe. The world we know has been growing and developing throughout 13.8 billion years, originating from the condition that came to be called the cosmic singularity. In order to research this process, astronomers have to literally look back at the past. When we talk about the boundaries of the universe, we imply only the limits seen to us. This visible area is called the metagalaxy, or the observable universe. But what lies beyond? Cosmo. The first in outer space. The statement that there are boundaries to the universe is considered per se one of those great ideas which are able to dramatically change our world perception. Something similar took place back in 1543 when Nicholas Copernicus proved that the Earth wasn't located in the center of the cosmos. The following breakthrough took place in the 20th century when Edwin Hubble showed to the world that galaxies moved away from each other. This prompted the idea that the universe hasn't existed eternally and was formed as a result of a certain event, the Big Bang. Today we are certain that the dimensions of the world we live in are much larger than we are capable of imagining. The search for the answer to the question about its boundaries is going to lead to yet another scientific breakthrough. At the moment, scientists are able to talk only of the boundaries within which the objects are visible. This area is also called the observable universe. That is its part which is the absolute past in relation to the observer. The cosmic horizon is the boundary of the observable universe. The objects on the horizon become infinitely redshifted, that is, they constantly move further away. The number of galaxies within the observable universe is estimated at upwards of 500 billion, with this number increasing on a regular basis as the research equipment becomes more advanced. But how big is the observable area of the universe today? The distance to the remotest observable object equals approximately 14 billion parsecs in all directions. Thus, the observable universe is a sphere with a diameter of about 93 billion light-years and with the center inside the solar system. That is, it is centered on the observer. The area equals 350 quinvigintillion cubic meters. It should be mentioned that the light emitted by the furthermost observable objects has been traveling for 13.8 billion light-years before reaching us. However, the distance to those objects has significantly grown due to the never-ceasing expansion of the universe. This process is the result of there being matter and energy in space, filling space-time. While there is matter in space, there is gravitational force. Therefore, the universe either shrinks, affected by gravity, or expands, affected by dark matter. It is also worth noting that there isn't a single center for the universe's expansion, just like there isn't a space for the universe to expand into beyond its boundaries. This process takes place with the matter in space at any point, everywhere and at all times. We do not physically perceive this, as the force holding our atoms and molecules together does not allow us to burst under the influence of the space expansion. This may be compared to a baking loaf of bread, with the raisins for galaxies and similar formations and the dough for the space matter. According to estimates, the distance to the furthermost observable objects today equals approximately 14 gigaparsecs, or 46 billion light-years. The furthermost stellar system with respect to the Earth is a galaxy dubbed GNZ11. Its light has been traveling to us for about 13.4 billion years, meaning that this object was formed less than 400 million years after the Big Bang. However, due to the constant expansion of the universe, today's distance to GNZ11 is approximately 32 billion light-years. One may argue that the speed with which it recedes exceeds the speed of light, but it does not clash with the special theory of relativity, as it isn't the matter that is receding, but the space between the two objects is growing larger. This object is supposedly one of the very first galaxies and is likely to be the closest stellar cluster to the edge of the observable universe. If man were able to freely travel from one world to another, it is in that galaxy that we might find out about the genesis of our world in more detail. What we call the meta-galaxy is likely to have started to expand immediately on its birth. In theory, the boundaries of the meta-galaxy may well reach the cosmic singularity. That is, it may show us what the world had been like before the Big Bang, but in practice it is relic radiation that is the limit to the observable. It is this radiation that is emitted by the furthermost object in the universe to have been observed in contemporary science. This radiation poses something like a barrier for our vision. It came about approximately 380,000 years after the Big Bang. That is, at the time when the universe cooled off sufficiently for atoms to emerge. In plain English, it is similar to an image of space in its childhood, where it is depicted before the formation of the first stars. It is likely that the universe stretches infinitely beyond this barrier, and it is there that its hypothetical boundaries are to be found. The objects beyond this barrier are referred to in a number of ways: multiverse objects, parallel universe objects, to name but two. Science today is incapable of defining these bodies with any detail. However, assuming that the universe carries on expanding, we may conclude that the objects we're able to observe now are sooner or later going to disappear from our field of vision. If the accelerating expansion of the universe continues indefinitely, the galaxies beyond our supercluster are sooner or later going to recede beyond the horizon as a result, thus becoming invisible to us. Any form of communication beyond the boundaries of the observable universe will be rendered impossible, and any contact between the objects will be lost. The Earth, the Solar System, the Milky Way and our supercluster will be mutually observable, whereas the rest of the universe will recede in the distance. There may be hypothetical worlds beyond the regions observable to us. They originate as a result of phase transitions of physical vacuum. Alternatively, there may be objects forming out of irregularities of relic radiation located closest to the particle horizon. The question of multiverse objects remains a bone of contention among scientists, prompting an overwhelming number of pseudo-scientific guesses. Be it as it may, most researchers see eye to eye as to the infinity of our universe, although they interpret it in different ways. Some of them claim our world to be multidimensional, which makes our three-dimensional universe merely one of its layers. Others are inclined to believe in the theory of a multi-universe, with us as a minuscule fraction of an infinite multitude, whereas there may be a portal to other worlds beyond the observable area of the universe. Some space theories involve the existence of the so-called event horizon. According to this concept, we're never going to be able to look beyond the event horizon, because the speed at which photons travel away from us will be higher than the speed with which the observable universe expands. According to this theory, all the galaxies surrounding us are bound to recede beyond the event horizon. It will look like time stopped in them. We will observe them infinitely receding beyond the observable boundaries, but never quite disappearing from view. Be it as it may, contemporary science cannot provide a definite answer to this question, although the situation may change overnight once we have developed more advanced observation equipment. The universe might turn out to be a sort of sphere, and traveling over it might remind one of traveling on the spherical surface of our Earth. Considering the scale it reaches, however, This prospect appears impossible. In order to reach the edge of the observable universe, it would take man 46 billion years, even if we travel at the speed of light. By the time we reached this designated point, it would have moved the same distance away, and a similar journey would have to be embarked upon. It is likely that there aren't any large objects beyond the observable universe, and on peering there, we would see just a homogeneous cloud of helium, hydrogen, and a few other elements. However, we might probably never be able to discover the origins of our world, and might forever remain in the position of someone chasing the horizon. I hope you have enjoyed this video. If you have, why not hit the like button and subscribe? This way you will not miss the new videos. Keep in touch.